Hello all, myself Joseph Vianney, working as an assistant professor in the Department of Civil Engineering from VSB Engineering College, Autonomous Karur. So in this video I am going to discuss about the analysis of truss. So before entering into the topic, we must know some basic concept of a structures, so how they performing, that's what I am going to discuss now. The primary function of a structure is to receive loads, usually unknown service loads, at certain points and transmit them safely to some other points. For instance, of a building frame receives occupancy loads of the building besides the self-weight of the structural components. Similarly, a highway bridge has to support the live load due to the traffic and the dead load of the bridge itself besides several other loads. The structural system of the bridge has to be designed so as to transmit these loads safely through the supporting piers and abutment of the foundations. In performing this primary function of receiving loads at certain points and transferring them safely to some other points, the structure develops some internal forces in its components. It is the responsibility of the structural engineer to design the all structural elements of a structural system in such a way that they perform their functions adequately. The inadequacy of one or more structural elements may lead to the malfunctioning or even collapse of the entire structure. The object of structural analysis is to determine the internal forces and the corresponding displacements of the structural elements as well as those of entire structural system. The safety and proper functioning of the structure can be ensured only through a structural analysis. The importance of a correct structural analysis for the proper functioning and safety of the structure cannot be therefore be overemphasized. So next I am going to give an introduction to truss. A truss is an assembly of several members connected by welded or riveted joints that creates a rigid structure. In engineering, truss is called as two-force members. A truss simply carries axial force only, as truss is pin jointed. 2D truss is called as pin jointed plane frame and 3D truss is called as pin jointed space frame. Both frames are taking only axial forces. Axial forces may be compressive or a tensile. The top members of the truss is called as top chords and the bottom members are called as bottom chords. The interior members of the truss are called as webs. For simply supported truss, top chords are in compression and bottom chords are in tension. For a cantilever truss, top chords are in tension and bottom chords are in compression. Okay, so next I'm going to discuss about the assumption that we are going to follow in the analysis of truss. Truss members are connected together at their ends only. Second one is the truss members are connected together by pins which is frictionless. And third one is truss is externally loaded at the joints only. And final assumption is the weights of the members are neglected for this analysis. So here in the below diagram we can see the simple two triangular truss. So here we have 4 joints and 2 supports. So in the at joint A we have a pin jointed support, at joint B we have a roller support. At joint D we have one vertical member, vertical external force which is P. So as I discussed previous, the basic building blocks of a truss is a triangle. Large truss are connected by attaching several triangles together. A new triangle can be added truss by adding 2 members at the joint. A truss constructed in this fashion is known as a simple truss. Right. So next I am going to discuss about the method of joint. So in the analysis of truss we have 2 steps. First one is finding support reactions and second one is finding forces in the members. The support reactions can be easily found using the equilibrium equations or conditions, which are summation h equal to 0, summation v equal to 0 and summation m equal to 0. The forces in members of the truss are found by using 3 methods. They are method of joints and method of sections and final one is graphical method. So in this video I am going to discuss only about the method of joints. So method of joints is very much easier compared to other 2 methods. So in the method of finding unknown member forces in the truss by applying equilibrium conditions to the joints, it is the only of the easiest way to solve the truss. After finding reactions at the supports, choose the joint in such manner that it should have only 2 unknown member forces, as we are having only 2 equilibrium conditions for the joints, which are summation h equal to 0 and summation v equal to 0. If the joint is having more than 2 unknowns, that cannot be solved by using method of joints. If the member's forces will be tensile if it is acting away from the joint. The member force will be compressive if the it is acting towards a joint. In case of cantilever truss, there is no need to find out reactions at the supports. The member forces can be calculated by taking joints from the free end. So these are the three steps we are going to follow in the analysis of truss by method of joints. First, we have to draw the free body diagram of the truss, and second one is determine the external reactions by applying equilibrium equations to the whole truss, and third one is perform the force analysis of the remainder of the truss by method of joints. So I am going to discuss one example regarding the method of joints method. So here we have three triangular truss which are connected with each other. So the supports are provided at the right hand side of the diagram. So this truss I am going to analyze by the method of joint. So first I am going to take the moment about the joint E, so which is summation ME equal to 0. So 5 times of T minus 20 downward force which is in the perpendicular distance at 5 meter. So minus 20 into 5. So minus indicates it is in downward direction. Minus 30 kilonewton is also in the downward direction. That's why here we have a minus value. So minus 30 into perpendicular distance is 10, which is equal to 0. From that we can easily calculate the T value, which is 80 kilonewton. Next I am going to choose the condition summation Fix equal to 0. 80 cos 30 because it is in 30 degree triangular angle. So if we want to analyze the horizontal force, we have to use the cos. If we want to analyze the vertical force, we have to use the sine. So 80 cos 30 degree minus Ex equal to 0. From that easily I can calculate the Ex value, which is 69.3 kilonewton. Next I am going to choose summation Fi equal to 0 condition. So 80 sine 30 degree. If I want to resolve the vertical forces, I have to choose sine. So 80 sine 30 degree plus Ey minus 20 minus 30 is equal to 0. So minus before the numerical value is 20 and 30, that indicates it is in downward force, which is equal to 0. From that I can easily calculate the Ey equal to 10 kilonewton. So next I am going to choose the joint A to resolve the forces. Right, so summation Fx equal to that what I am going to choose at first. So 0.866 RB minus 30 is equal to 0. So from that I can easily calculate the RAB, which is equal to 34.6 kilonewton, which is in tensile. So positive values can be considered as tensile and the negative values can be considered as compressive. So next I am going to choose the condition summation Fi equal to 0. RAC minus RAB cos 60 degree is equal to 0. From that I can easily calculate the RAC because I have calculated the RAB in previous steps. So 17.32 kilonewton, which is in compressive because the value is in minus. And then I am going to choose the joint B because after completion of joint A, it is better to choose the nearby joint. If I choose joint C means totally we have 4 members which are connected at joint C. That's why I am going to choose the joint B for easy calculations. So Fi equal to summation Fi equal to 0. That's the condition I am going to choose first. So RAC RB or RBC sin 60 degree minus RAB cos 30 degree, which is equal to 0. From that I can easily calculate the RBC value, which is 34.6 kilonewton. That is a tensile force because the value which I got is plus value, which is positive value. Summation Fx equal to 0. RBD minus RBC cos 60 degree minus RAB sin 30 degree, which is equal to 0. From that easily we can calculate RBD because all other values we have already found in previous steps. So the RBD value which I got is 34.6 kilonewton, which is tensile force. And then I am going to choose the joint C because after completion of joint A and joint B, it is better to go to joint C. So in the joint C we have 4 members and we have one vertical force which is 20 kilonewton, which is acting downward. So first I am going to choose the condition summation Fi equal to 0. So minus RBC sin 60 degree minus RBD sin 60 degree minus RE minus 20 is equal to 0. From the easily I can calculate the RCD value, which is minus 57.7 kilonewton. Actually it is a plus value, that's why I put in tensile force. Then summation Fx equal to 0. RDE minus RCD cos 60 degree plus RAC plus RBC cos 60 degree is equal to 0. From that easily I can calculate the RCD value, which is minus 33.5 kilonewton, which is in compressive. And finally I am going to choose the joint T. So after completion of joint A, joint B, joint C, it is better to go to joint C, joint E. So after completion of joint E, we can easily calculate the all other member forces, right? So first I am going to use the condition summation Fi equal to 0. The equation which I got is minus RDE sin 60 degree, which is equal to 10. And then RDE equal to, which is can be calculated as 11.55 kilonewton. The value which I got is minus value, that's why I put compress in the bracket. So far we have calculated all other member forces which are but it is better to tabulate it for easy identification. So I split the tabular column into 3 columns. First one I mentioned as member, second one is member forces is in kilonewton, and third one is nature of the force. So in member force I am going to select all the members which are available in the given figure, and I am going to I have written all other forces which are calculated in the second column which is shown here. So which is 34.6 kilonewton for AC, 17.32 kilonewton for BC member, 34.6 kilonewton, and for BD member 34.6 kilonewton also, and CD member 57.7 kilonewton, and CE member 63.5 kilonewton, and finally I have calculated DE which is 11.55 kilonewton. The nature of force can be easily identified by the plus or positive or negative value of the given what we have found in previous steps. Right, the positive means it will be tensile, and the compressive means it is minus value. Okay, so this is what I have concluded my video. So this is a very useful method for you to analyze that truss for a future. Thank you.